Ni hao, students. Today we're going to talk about ratios, rates, and proportions. So they're all connected. So once you know about one of them, you pretty much know all of them. They're just some minor details. Now, idea of a ratio, it's just comparison of two items, right? And you can write it in three different ways. You can write it as a fraction, you can write it in words, and then you can write it using the idea of a colon in between. All means the same thing though, because if we have three ovals and we have two rectangles, well, you write that as a fraction of 2 to 3, 2 to 3, 2 to 3. I just said the same thing. Why? Because they're all the same thing. And a ratio is just comparing numbers. Okay? Now, when you get into a rate, it's the ratio with units. And remember, units would just be something like miles or hours or words or minutes. It's just telling you what it is that's connected with a number. And that's the only difference between a rate and a ratio. So here we have 60 miles per 3 hours. If we break it down into something called a unit rate, well, what is that? A unit rate is when we have a rate with units, okay, where we're comparing an amount compared to only one of something else. So in this case, what's happening? Well, we're comparing the 20 miles to just 1 hour, the 20 words to just 1 minute, and that makes it a unit rate. When you go to the grocery store, they give you a price. How much is the cereal? $5. $5 per one box. Now, when you see this written out, a lot of times you'll see it like this: 20 miles per hour, 20 words per minute. And those are unit rates, okay? Now, moving on to proportions. And when you say something is proportional, that really means that they're equal. Two things are equal. And what you're doing here is you're comparing two ratios. The ratio of 1 to 3, or 1/3, is equal to 2 to 6. And then, of course, how do you go and make one ratio equal to the other? You can multiply the top and bottom by the same number. Take a look at a couple proportional fractions, and of course these are going to be equal. If we have 3 divided by 5, or 3/5, equals 21/35, this might be, a little bit difficult to know right away if they are equal. And one way we can do that is by cross product or cross multiplying. So you take the denominator of the first fraction and multiply by the numerator, and then you just do the exact opposite. Take the numerator multiplied by the denominator, and they should give you the exact same answer. Now, why is this really, really good for us? Well, we won't always have numbers that we know. I mean, 3 times 7 is 21, 5 times 7 is 35. That's pretty easy. But what happens if you have one of the fractions with a variable? And that's exactly why we use the idea of a cross product. So let's just go ahead and do that. We're going to follow the same rules. We're going to multiply the 5 times the x, and that gets us 5x. We're going to multiply the 12 times 15, and that gets us 180. But now we just have a simple algebra problem. Divide both sides by 5. This goes to 1x, and 180 divided by 5 is 36. So that's why we're going to use the cross product. So remember, the cross product makes it nice and easy to solve for a variable. So let's take a look at this last example problem. In this problem, it seems a little more complicated because you have 3/2 equals 5 over x plus 1, but we're going to use the idea of cross products. So we're going to multiply those two, and we're going to multiply these two. And remember, the key is that they should equal each other. So let's just do this, but we're going to write it out. So in this case, we're going to have 3 times x plus 1. I'm going to put this in parentheses, and you'll see why, equals 5 times 2. Now, anytime we have a number outside of parentheses, first thing we're going to see if we can combine the terms, and we cannot. And then because we cannot, well, we'll fall back on our distribution. So 3 times x is 3x, 3 times 1 is 3, and over here we can do our multiplication. Now you see you have an algebra problem that you can without a doubt handle. It's a two-step problem, so we'll do that. We'll subtract 3 on both sides, and we get 3x equals 7. And then we will do our division. Here's our second step. And we are left with x equals 7 over 3. Now, I know this might seem a little bit strange. Well, okay, this x equals a fraction. I mean, that's the correct answer, though. They're not always going to be beautiful numbers like we had over here. So that's why we're going to use our cross product to help us solve for a variable within the proportion. Okay, good luck.